Good morning, girls. How are you? I hope you are all fine. And our lesson for today is algebraic representations of transformation. Here we studied in the last 3 subjects. We had 3 kinds of transformations: translations, rotations, and reflections. Here we have to show them algebraic way. We have to represent those transformations in algebraic representations. Our objective for this lesson is how can you describe the effect of translation, rotation, or reflection on coordinates using an algebraic representations. That means we have to represent those transformations in algebraic way. Okay, we have a formula for each of the transformation. First of all, we will discuss about the translation, algebraic representation of translation. Here we have this formula: write A units. If there is a unit, right, if they say move to the right 6 units or right to 3 units or 4 units, in the place of A, this is a variable, in the place of A we will write the number and we will add to the x coordinate, because moving to the right or moving to the left, that means we are moving along with the x coordinate. And up and down, moving up and down is moving along the y coordinate. So moving up means adding that number to the y coordinate. Moving down means subtracting that number from the y coordinate. Here, write A unit. That means we will move A unit to the right. That means that number will be added to the x coordinate. And left A units means subtract A from the x coordinate. Subtract that number from the x coordinate and y will be the same. B units, add B. B is a variable, it can be any number. Add B to the y coordinates, x and y. That means that number will be added to y. Down B units means subtract that number from the y coordinate and x will be same. Now here we have a your turn. We have a question. Your turn 1 is: a rectangle has vertices 0, -2, 0, 3, 0, 3, -2, and 3, 3. What are the coordinates of the vertices of the image after the translation? The question is already given here. X and y, x minus 6, y minus 3. We have to describe this translation. These were our coordinates: 0, -2, 0, 3, 3, -2, 3 and 3. They already gave us a formula to use: x -6 and y -3. So all the x coordinate we will subtract by 6 and all the y coordinates we will subtract by 3. So we will write those numbers here: 0 minus 6, -2, the y coordinate -2, minus 3, 0 x coordinate x minus 6, 3 here, 3 minus 6 here. These are all x coordinates subtracted by 6. Y coordinates subtracted by 3. These are our prime, the result coordinates, x prime and y prime. These are our 4 points that we got. This is the translation of this question. This is how we will find the translation. Now let's move to the algebraic transfer representation. This is the formula for algebraic representation of reflection. Each and every transformation has their own formula. So if the image is across x-axis, then the coordinates will be changed according to this. X will remain same, y will be negative. If the image is across y-axis, then coordinates will be changed according to this. These are the formulas and the coordinates will change according to this. Now we have a your turn 2. Triangle ABC has vertices A, -2, B, 0, 5, C, 3, -1. Find the vertices of triangle A prime, B prime, C prime after reflection across the x-axis. In the formula table of the formula, it's already given. If the reflection is across the x-axis, which formula we will use? If the reflection is across x-axis, this means this. The first one we will use. the coordinates will be written like this: x and negative y. X will remain same, only the y will become negative. Here we have this. These were our coordinates for your turn 2. We will write them according to this. X will be same, y will be negative, and our prime vertices are these. Now this is algebraic representation of rotation. These are all the formulas that we studied in the last lesson for rotation. Now here we have, if we have to rotate it clockwise, then 90 degree, then x and y will be the after reflection, this will be our coordinates. If we have to rotate it counterclockwise, that is anti-clockwise, then this is our formula. These are all the formulas that we studied in the last lesson. You have to memorize these formulas. Now we have your turn 4. Here we have a triangle has vertices J, K, L with these coordinates. What are the coordinates of the vertices of the image after the triangle is rotated? Now we have to we already know, if we have to rotate the image 90 degree counterclockwise, the x and y coordinates will be written like this: negative y and x. This will give our image. When we will move and change them according to this, this will give our image. This is question number 1 from guided practice. Here are our coordinates. We have to write it according to this. Translation of 6 units to the right. Right means x plus. On the across x-axis, plus 6. X plus 6, y. These are our new coordinates, and this is the image for this. This is our second question and third. Everything is given and the chapter is clear.